All right, welcome everybody. What we're going to do is we're going to talk about the periodic table. Specifically, we're talking about patterns in the periodic table, and I'm going to try and keep this as simple as I can. Remember that matter can be divided into pure and impure substances, right? Yeah, so matter can be divided into pure substances and mixtures, and pure substances can be divided into elements or compounds, and mixtures can be divided into homogeneous mixtures, which have one phase, you can't see the difference, or heterogeneous mixtures, which you can see the different bits and pieces in them. Now we're going to talk about elements today because elements are what are on the periodic table. And what are elements? Well, elements are just a whole bunch of atoms of the same type. So a bar of gold, for example, has a whole bunch of gold atoms. And if we say I got a piece of elemental gold in front of me, imaginary between my fingers, I don't have that much money to have a piece of gold, but it would be made up of many, many atoms, okay? And so elemental gold is made up of many, many, many atoms. So when we arrange those elements on the periodic table, it helps us explain and helps us predict the different physical and chemical properties of those elements. This means that if we know that an element is somewhere on the periodic table, we can predict what its chemical and physical properties are going to be by looking at the other elements that are around it. So the periodic table is divided up into periods, which is from left to right, and groups, which go up and down. Now groups, we're going to learn, have similar properties, okay? So up and down things have similar properties. Let's look at the periodic table. So this is a period from left to right. This represents the first period, everything up here. That's the first period. This is the second period, third period, fourth period, and so on. It goes down to 7 periods. Don't worry about these guys yet. We'll talk about them later. Up and down, we have groups. This is group 1. This is group 2. Okay? So I don't want you to worry about any of these guys right now, but we skip all these guys, and we call this group 3, 4, 5, 6, 7, 8. Okay? And sometimes they'll even put an A beside here. Okay, 4A, 5A, 6A, 7A, 8A, and I'll explain to you why later. We're not so concerned right now about that. So, in group 1, these guys are right here, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. You have what we call the alkali metals. I'm going to show you these in class. These are pretty cool. They're very reactive. They have what we call one valence electron. Okay, they all form a charge of 1+. We're going to figure out why that is, and they often bond with halogens. In group 2, right here, we have the alkaline earth metals. If you look on your periodic table, you see that it's actually labeled as such, alkaline earth metal on your periodic table. They have 2 electrons in their outer shell. We call these valence electrons again, and we'll learn what that means. And they have a charge of 2+. In the middle of the periodic table, the guys I said don't worry about, these guys are known as the transition metals. Okay? Alright. And then we have the metalloids, which is the guys on the staircase that separate the metals from the non-metals. So there's actually a staircase on the periodic table. If you take a look, I'm going to draw it in right here. Let me make sure I get this right. That's the staircase, and on this side, everything to the left, all these guys here, okay, including the ones below, are known as metals, okay? Everybody to the right of the staircase is known as nonmetals. So what is the periodic table mostly made of? Well, the answer is metals. It's mostly metals. Most of the elements in the world, most of the atoms, are metals. There is some nonmetals, and it turns out that what are we made of? We're mostly made up of nonmetals. Nonmetals are on the right side of the periodic table. They're actually hard, brittle, and dull. They have negative charges. And I said group 17, but I'm going to call this group 7A, and we'll explain why. And one thing that you'll notice is that they have 7 electrons in their outer shells. We're going to find out that they're poisonous. Halogens, chlorine, bromine, iodine. They're all located in the group 17, which is right here, group 7, or 17, 7A. Fluorine, chlorine, bromine, iodine. Bromine we use in hot tubs to disinfect the water. Chlorine we use in pools to disinfect the water. We also drink chlorine. And fluoride we actually use to disinfect our water as well, and it actually strengthens our teeth. But they're all very, very reactive. Okay, so we also have another group that I'd like you to know. They're known as the noble gases, and they're group 8A. And we're going to notice that they have a very stable full outer shell. So the noble gases are located right here in this group here. Helium, neon, argon, krypton, xenon, radon. These guys all don't react. And we're going to talk about why that is as well. Alright, in summary, when we look at the periodic table, it contains all the elements. And how are they organized? They're organized in, these are called, what are they called? Groups. And I told you to number them 1 through 8. And you put an A beside them. It's fine. We'll talk about why that is later. And we also have periods, which is left to right. Now, what the most informative thing for us, what that means the most information we get from this, is if you can know the group, it tells you a bit about it. Group 1, these guys react the same. Group 2, they react the same. Jump over here to group 3, they're similar. 4, they're similar. 5, 6, 7, 8. What else do you need to know? Well, the periodic table is divided up into metals and nonmetals. Metals are on the left, and nonmetals are on the right. And they are separated by this little staircase. Elements that touch the staircase, they're known as metalloids. Elements that are in this weird zone that I said don't worry about it, they're known as the transition metals, because they're transitioning from metals to nonmetals. That's it. We're going to do more tomorrow. Hope you enjoyed it.